In this lecture, we will dive into two fascinating NLP tasks, text generation and translation, and learn how to harness the power of pre-trained language models for these purposes. Let's see how to activate GPU in Google Colab. To activate GPU, we will click on Runtime and select this option Change Runtime Type. Over here, we can select T4 GPU, and you might have a scroll down option instead of such pattern. So you can just scroll down and select T4 GPU over here and save it. So you can see over here we are allocated a T4 GPU and we can run our code easily now. Moving on to our first line of code. Here we are importing auto tokenizer class from the Hugging Face Transformers library. This class provides a simple interface to automatically select the appropriate tokenizer for a given pre-trained model. In the second line, we define a variable check with the value BERT base uncased. This variable holds the name of the pre-trained model we want to use. In this case, it is BERT base model with uncased lowercase tokens. Later on the third line over here, we are creating an instance of auto tokenizer class using from underscore pre-trained method, passing the check variable to specify the pre-trained model we want to use. The auto tokenizer automatically downloads the tokenizer associated with the specific model. Moving on to our next line of code. Here, this line calculates and returns the length of the vocabulary of the tokenizer, that is, the number of unique tokens in the BERT tokenizer's vocabulary. Now we will have a look at how to print tokens from the vocabulary list. So here, what's going on is we are converting the vocabulary dictionary into a list and storing it in the variable v underscore list. The next line over here prints the first 10 tokens from the vocabulary list. This gives us an idea of an initial tokens used in BERT tokenizer. In our next line of code, this is input text, which is a sentence we want to tokenize and encode. Over here, what's going on is this line tokenizes the input text S using the BERT tokenizer. Tokenization is the process of breaking the text into individual tokens that the model can understand. This line encodes the input text S into a sequence of token IDs. Each token in the text is mapped to the corresponding token ID from the BERT vocabulary. This resulting ID variable contains a list of token IDs representing the input sentence. Later on, these two lines of code simply print the tokenized form of the input text and the list of token IDs. And over here, this line decodes the list of token IDs back into text. The decode method takes the token IDs and converts them back into the original sentence. So summarizing this section of code, the entire code is for using the Hugging Face Transformers library to tokenize, encode and decode text using the BERT tokenizer. It also prints out the first 10 tokens from BERT tokenizer's vocabulary. In this code, we will delve into the exciting realms of natural language processing and also explore how machine can create human-like text and perform seamless language transition using pre-trained models. Before we start learning our code, this all the libraries are very important to be installed before you run our code. So moving on to our next line of code. So what are we doing over here is this code imports the transformers library, which is a popular library for working with various natural language processing tasks, which uses pre-trained models. This line over here, what it does is it sets the login verbosity to error level, which suppresses any warning messages that might be displayed during the execution of the code. After this, we will start our content generation. This library over here, transformers, it's created by Hugging Face and which provides easy to use APIs for various NLP tasks. So a pipeline is an API that performs NLP tasks, including text generation and various more tasks such as classification, sentiment analysis, and etc. So transformer pipeline method right over here, what it does is it is used to create text generation pipeline. In this case, we specify text generation as the task and GPT-2 as model uh, for text generation. GPT-2 is a pre-trained language model developed by OpenAI. Now transformer.set underscore seed 1. This sets the random seed to ensure reproducibility. This means that the same input will produce the same output each time the code is run. Later on over here we have selected one sentence and assigned it to our input variable. Now the generator object is used to generate text based on the given input text. We pass input text to generator along with some parameters. Now num underscore return underscore sequences equals 2. This specifies that we want two different generated sequences as output. And max new tokens equals 30. This sets the maximum number of tokens the generator can add to the input text in each generated sequence. Over here, the generated output will be printed using loop uh, and each generated text will be separated by a line of dashes, as you can see over here. This line of dashes is used to separate the generated text. Moving on to our next line of code, over here, we import the necessary components for the translation task. The auto model for sequence to sequence LM class provides access to pre-trained models specifically designed for sequence to sequence tasks like translation. The auto tokenizer class helps tokenize the input text so it can be processed by model. Now we will try to translate our English language to German. To perform the translation, we need to specify the source and target languages. In this example, we translate from English to German. The tokenizer is used to tokenize the input text. We preprint the text, translate English to German to the input text and then tokenize it. The return underscore tensors equals pt argument ensures that the output is in PyTorch tensors format. Model.generate method over here generates the translated output based on the tokenized input. We pass the tokenized input tensor uh, input 1 and input IDs over here to the model and specify max length equals 40, which limits the length of the generated output to 40 tokens. Finally, we use tokenizer.decode method to convert the output tensor back into human readable string. Output 1 and in braces 0. This is used to return the first member from the output 1 list, which comprises the T5 models produced token IDs. And skip special tokens equals to directs the tokenizer to omit special tokens from the decoded text such as CLS, SCP, and so on. These tokens are used and utilized internally by the model and have no impact on the output. In the next part of our code, what we are doing is we are just performing the translation from English to French using the same approach as before. That's it. This code demonstrates how to use the Hugging Face Transformers library to perform text generation and translation tasks with pre-trained models.